In our last set of lessons, we looked at rational functions and graphs. And we saw that rational functions are functions that form a ratio. We have a polynomial divided by another polynomial. In today's lesson, the first part, we're going to do a couple of examples of solving rational equations. Remember that an equation is something that we solve. When we say solve, we mean find the value or values of x, that if I plug them back into the original equation, I have a true statement. So we've looked at processes for solving linear equations and quadratic equations and higher order polynomial equations. So our first step is to recognize that we have a rational equation and have to use that process. We can see right here that we have an x in a denominator. That means it's a rational equation. Our first step is going to be to eliminate the x's from the denominators and get this back into a form, a linear form or a quadratic form that we know how to solve. We have to see what we're dealing with in the denominators. So my first step in solving rational equations is going to be to completely factor all denominators. In this equation, the only denominator we have is this x right here. This x is in a numerator, it has an understood 1 under it, and the -9 is the numerator, it has an understood 1 over it. So we don't have to worry about the x or the -9 over here. We're only worried about this x here. And obviously, just plain x is completely factored. So we can skip that step. My second step is going to be to find the least common denominator. And we call that the LCD. Excuse me, not the least common denominator, the least common multiple. Very different thing. Least common multiple. The LCM. What we're trying to find is the smallest possible thing that we can multiply every term by and cancel all of the denominators. In this case, my LCM is just going to be x, because that's the only term I have in a denominator. My next step is to multiply, and I'm going to put quotes around multiply, and I'll explain why in just a minute. Multiply each term by the LCM. So when I say multiply, that means I'm going to take each term that I had in the original equation, and I'm going to multiply each one of those by my LCM, in this case x. So I can see that I have my original equation, and then each term multiplied by x. But I put multiply here in quotes because my next step, before I actually do the multiplication, is to cancel. The whole reason that I multiplied each term by x was so that I could cancel. The first term doesn't have anything to cancel, there's no denominator. The second term, I have an x in the numerator, I have an x in the denominator, those cancel. The third term, I do not have anything to cancel. So what I've done here is I've canceled out everything in the denominator at that step. So now I multiply out what's left. So here I have x times x, which is x squared, plus on the middle one I have just 8, and over on the right I have minus 9x. And now we just have a quadratic equation, and we can solve that using our quadratic methods. Remember quadratic methods? Check for the b term. In this case, the minus 9x, we have one, so we get it in standard form, keeping x squared positive, set equal to 0, try to factor. So you guys go ahead and pause the video for a moment and go ahead and do that. All right, so we see that the x squared is already positive, so we bring the 9x over. And because we do not have a coefficient on the x squared, we know we're going to have x times x. And we think of two numbers that multiply to give me 8 and add to give me 9, which are plus 8 and plus 1. And then we can solve each of those, and we get x equals 8 and x equals -1. Now, when you're dealing with a rational equation, we had this x in the denominator in the original equation. That means we have to be careful about what values of x that we can use. We cannot use any value of x, any solution, that if I plugged it back into the original equation, it would give me division by 0. So I have to double check. If I put a -8 in, -8 is not 0. If I put a -1 in, -1 is not 0. So both of these answers check. So my solution is x equals -8 and x equals -1. If I were to plug either one of those numbers back into the original equation and work it out, I would have a true statement. That's what it means for these to be solutions. If you wish to check those, you may, but it is not required. But our 7th step here is we definitely always, with rational equations, is have to check for division by 0. And if we have a value of x that does give division by 0, then we cannot use that solution. Okay, let's do another example. I want to go ahead and start a new page here. (5x plus 7 over x minus 1 equals 24 over x minus 1 over x squared minus 1 plus 5x minus 7 over x plus 1. All right. And our instructions would be to solve. In other words, find the value or values of x that if I plug in would make this a true statement. All right. I want you to review back over your steps that we looked at in the first example. First step, factor all the denominators. So go ahead and do that. And we see that this middle one is x plus 1 times x minus 1. Notice on the first denominator, we had just x with no x squared. We did not have any common numbers that we could factor out. So that meant that was completely factored. On the middle term, the middle denominator, we had an x squared. That meant that it could be factored. And then on the last term, we have x plus 1. The x is just to the first power, and there's no common numbers that can be factored out, so that one's completely factored. Our next step is to find the least common multiple. To do that in a systematic way, we're going to look at the first denominator, and we know we need at least x minus 1 to be able to cancel that x minus 1. So we add it to our LCM. Then we look at our second denominator, x plus 1 times x minus 1. So we think, do we have an x plus 1 to cancel the x plus 1? We do not, so we have to add that on. Then we look back, we have an x minus 1. We need an x minus 1 to cancel that x minus 1. We look back at our LCM. Do we already have an x minus 1? And yes, we do. So we don't need to add another one. Then we move to the third term, and we have x plus 1, which we already have, so we don't need to add another one. So our LCM is x minus 1 times x plus 1. Our next step is to multiply every term in the original equation by the LCM. And remember that we're not actually going to multiply anything out at this step. We're just putting it beside it as if it were multiplication. And we do need to put each of these in parentheses because we're going to need to multiply those all out later. So we're multiplying each term by the LCM. And I recommend that you go ahead and put the LCM individually with each separate term, because then you can see individually what's canceling in each term. You go ahead and do that. You go ahead and do the next step and cancel what's common in the numerator and the denominator of each separate term. And we see that we can cancel x minus 1 here. On this one, the x minus 1 and the x plus 1 cancel. And then on the last one, the x plus 1 cancels. So my next step is to write out what's remaining. And I'm not going to try to do any foiling or multiplication at this point. I'm just going to go ahead and just recopy what's left. On the first term, I have 5x plus 7 and x plus 1 are remaining. You go ahead and do the next two. Just write what's remaining after you've done all your cancellation on the next line. And I see that I have 24 from the middle term plus, that's this plus here, 5x minus 7 times x minus 1. All right. At this step, be very, very careful with your numbers and your signs as you copy them down. Recopying incorrectly is a mistake a lot of students make at this step. Okay, now we can FOIL out and get an equation. Do that. Go ahead and pause the video and then restart when you're ready. So when I FOIL this first part out, 5x times x is 5x squared, 5x times 1 plus 7x plus 7. The 24 just drops down, the plus just drops down, and then plus 7. Now I'm going to combine like terms on each side separately. All right, and I have that. Now, we can go ahead and solve this equation. At first glance, this looks like a quadratic, but we see that when we start trying to combine like terms, when I subtract the 5x's cancel, and I'm just left with the linear equation. You go ahead and pause the video and solve that linear equation. To solve the linear equation, we want to get all the x's on one side and all the numbers on the other. So we have a negative 12x. We can add 12x to both sides. We end up with 24x. We want to subtract the 7. And we end up with 24. 31 minus 7 is 24. We divide both sides by 24 and x equals 1. So we have solved our equation. If you did not get x equals 1, go ahead and pause the video and look back over your work and see where you made your error. When you're ready, restart. The equation that we solved was this one, to get the solution x equals 1. If I plug x equals 1 back into this equation, I would end up with a true statement. But remember that the equation that we were originally trying to solve, and I'm just going to write it again very quickly here because it's difficult to see what I had after I wrote all over it. So this was my original equation. If I tried to plug x equals 1 back into the original equation, I would get 1 minus 1, which is 0. I can't have that. I cannot have 0 in the denominator. So the only solution that I have, x equals 1, cannot be used because it gives division by 0. So that means that this equation has no solution. We didn't do anything wrong. This was the only way to solve it, but then the one number that might have worked we could not use, so we have no solution. On our next video, we're going to do a more difficult problem. So go ahead and look at the video, Solving Rational Equations, Part 2.